Hey guys, in this one we are looking at probability questions involving a relative frequency. So, a relative frequency is the number of times an event occurs out of the total number of trials. So, if I flip a coin 10 times and get 7 heads, the relative frequency of heads is 7 tenths. Alright, let's go. Okay then, first up, a coin is thrown 50 times and lands on heads 31 times. Write down the relative frequency it lands on heads. So that's 31 times out of 50 throws. Part B. Raj says the coin is biased towards heads. Give a reason why Raj might be correct. Alright, so biased towards heads means it's more likely to land on heads. So, with a coin, we would expect it to be 50-50 heads and tails. So, it's landed on heads a lot more times than on tails. So because of that, Raj might be correct. Number 2. So a biased dice is thrown. The table shows the probability of each score. The dice is thrown 200 times. We want to work out the expected number of times the score will be odd. So what we're going to do here is work out the probability of odd, and then we multiply that by 200, and that will give us the expected number of times the score is odd. So the probability of odd is the probability of 1, 3 and 5 added together. So that's 0.25 add 0.15 add 0.3, so that's 0.7. So that's telling us we expect the score to be odd 70% of the time. So we now do 0.7 times 200. And that gives us 140. But 3 on 3 days, Ellie throws darts at a target. So we have Monday, Tuesday, Wednesday, total number of throws, number of hits, number of misses. Part A. Work out 2 different estimates for the probability of Ellie hitting the target. Alright, so we can use relative frequency to estimate probability. So, if we use Monday, he hit the target 15 times out of 20. So that's 1 we could use. Now that's the same as 3 quarters. And another one we could use would be on Tuesday. So he hit 22 times out of 30. So that's 22 out of 30. Which we could write as 11/15ths. Okay, then part B asks which one of our answers gives the better estimate of the probability he hits the target. So, the more times we do a trial, the more accurate our results. So our most accurate one here was 22 out of 30. And that's because there were a greater number of trials on Tuesday than there were on Monday. Now, to get the absolute best estimate, we would use all the data, so all 90 throws. So out of 90 throws, he hit the target 54 times. So the best one would be 54 out of 90. Number 4. A game has the results win, lose or draw. After 80 games, the relative frequency of win is 0.4 and the relative frequency of lose is 0.25. And then we're asked how many of the games had the result draw. Alright, so what we can do here is work out the number of games that were won and the number of games that were lost, and then subtract that from 80. So the number of wins so we do the relative frequency, which is the probability, times 80. So 0.4 times 80. Now that is 32. Okay, and then the same for the losses. So that's 0.25 times 80. Which is 20. So 20 add 32 is 52. So the number of draws is 80 minus 52. And that gives us 28. Next up, Stuart throws a biased coin 10 times and gets 7 tails. Maxine throws the same coin 50 times and gets 30 tails. Prasha is going to throw the coin once. Whose results give the better estimate for the probability Prasha will get a tails? Give a reason for your answer. So it's Maxine, because she threw the coin more times than Stuart. So we could say a greater number of throws. Okay, then part B wants us to use Stuart's and Maxine's results to work out an estimate for the probability pressure gets a tails. So what that wants then is the total number of throws, so that's 10 and 50, and then the total number of tails, so that's 7 and 30. So the probability of tails can be estimated as 37 out of 60. Question. So when a drawing pin is dropped, it can land point down and point up. Lucy, Mel and Tom each drop the pin a number of times, and we have the results in the table. Rachel is going to drop the pin once, whose results give the best estimate for the probability the pin will land point up. Alright, so again, we need to know who dropped the pin the greatest number of times. So let's put total. So Lucy was 31 and 14, so that's 45 times. Mel 53 and 27 is 80. And then Tom 16 and 9 would be 25. So Mel's results would give the best estimate because she dropped the pin the greatest number of times. So the probability using her relative frequency would be 27 out of 80. And for part B, Stuart is going to drop the drawing pin twice. We want to use all the results in the table to work out the probability the pin will land point up and then point down. So when it says use all the results in the table, we want to work out overall relative frequencies. So we're going to need the total number of times the pin was dropped. So 45 and 80 and 25 is 150. Okay, now we can work out the total number of times it landed point down. So 31 and 53 is 84, and 16 is 100. So that means it landed point up 50 times. Alright, so the probability then that we're going to use for point up is 50 out of 150. Which is 1/3. And then the probability it lands down is 2/3. So the probability it lands up and then down is, now when we have successive events, we multiply the probabilities together. So it's 1/3 times 2/3. And that gives us 2 notes. And guys, that's the end of this one. Really hope it's helped. Next up, we are looking at harder probability word problems. Hope to see you there.